Think about the last time someone rejected you. Maybe it was a person you liked. Maybe it was a job you wanted. Maybe it was a message you sent that never got a reply. You remember the feeling, that hollow, heavy weight in your chest, the kind that makes it hard to breathe. And you probably told yourself the same thing most people tell themselves. It's just an emotion. It will pass. It isn't real pain. But here's what nobody told you. The part of your brain that processed that rejection is the same part that processes a broken bone. Not metaphorically, not poetically, literally, neurologically the same. And once you understand why, you will never look at rejection the same way again. In 2003, psychologist Naomi Eisenberger at UCLA ran an experiment that changed how scientists understood the human brain. Participants were placed inside an MRI scanner and asked to play a simple virtual ball-tossing game with two other players. What they didn't know was that the other players were computer programs. Halfway through the game, the programs stopped throwing the ball to the participant. They just excluded them. No explanation, no confrontation, just silence. The MRI scans showed something that stunned the research team. The anterior cingulate cortex, the region of the brain that registers physical pain, lit up in response to social exclusion with the same intensity it would if someone had been physically hurt. The brain wasn't treating rejection as an emotional event. It was treating it as damage. But why? Why would evolution wire your brain to process the loss of a social connection the same way it processes a wound? Now, to understand this, you have to go back about 50,000 years. Your ancestors didn't survive alone. They survived in groups, small, tight bands of people who shared food, protection, and knowledge. Being part of that group wasn't a comfort. It was the only reason your ancestors were alive at all. A human expelled from the tribe in that environment had almost no chance of surviving more than a few days. No fire, no food, no protection from predators, no one to care for them if they were injured. Exclusion from the group was a death sentence. So your brain evolved a system to prevent it. A system so powerful, so immediate, and so impossible to override that it used the most urgent signal the body already had. Your brain learned to treat the threat of social loss the same way it treated the threat of bodily harm. Because in the world your ancestors lived in, they were the same threat. Here's where it gets stranger. Researcher Kipling Williams at Purdue University spent years studying what he called ostracism, the experience of being ignored or excluded. In one series of experiments, he found that even the briefest experience of social exclusion produced measurable drops in mood, self-esteem, and sense of control. Even when participants knew the exclusion was random, even when they knew the people excluding them were strangers they would never meet again, even when they were told explicitly that the exclusion meant nothing, the brain didn't care. The alarm had already fired, and this is the revelation that changes everything. Your brain cannot tell the difference between being excluded by someone who matters and being excluded by someone who doesn't. It cannot distinguish between a devastating rejection from a person you love and being ignored by a stranger in a game that lasts 3 minutes. The pain response fires regardless. The wound registers the same. This is why a throwaway comment from someone you barely know can ruin an entire day. This is why being left out of a group chat you didn't even want to be in stings more than it should. This is why you replay a rejection over and over at 3 a.m., even though every rational part of your brain knows it doesn't matter anymore. Your ancient alarm system doesn't do proportionality, it just does danger. But the research goes even further. Naomi Eisenberger and her colleague Matthew Lieberman took their findings one step further and tested whether the same neural overlap worked in reverse. If rejection activated physical pain pathways, would a physical painkiller reduce emotional pain? They gave participants acetaminophen, a common over-the-counter painkiller, for 3 weeks and tracked their emotional responses to daily social interactions. The participants who took the painkiller reported significantly lower levels of emotional pain from social rejection compared to those who took a placebo. A painkiller, designed for headaches and muscle aches, reduced the pain of social rejection in a controlled scientific study. That single finding reframes everything. Emotional pain from rejection isn't a weaker, softer version of real pain. It is real pain, running on the same hardware, processed by the same systems, registered by the same brain. Now, think about what this means for the world you actually live in. Your ancestors faced rejection from a group of 50 people they knew for their entire lives. The stakes were real, but the scale was contained. Today, your rejection can come from hundreds of directions simultaneously. A post that gets no engagement, a message left unread, a comment that nobody responds to, a job application returned with a form letter, each one small, each one triggering the same ancient alarm that once signaled mortal danger. Your brain was built to handle rejection as a rare, high-stakes event. Instead, it now handles it dozens of times a day, in environments your ancestors never could have imagined, and it responds to each one with the full force of a system designed to keep you alive. Psychologist Mark Leary, who developed what he calls sociometer theory, argues that your sense of self-esteem isn't really about how you feel about yourself. It's a gauge, constantly updated, tracking how accepted or rejected you are by the people around you. When that gauge drops, the pain response fires, not as a flaw, as a feature. It was designed to motivate you to repair the social bond before it was too late. The problem is that the gauge was calibrated for a world where every rejection had consequences you could see, evaluate, and respond to. A world where the person rejecting you was standing right in front of you. A world where you had the chance to understand what went wrong and fix it. Today, most rejections are invisible. A door that closes without explanation. A silence that gives you nothing to work with. And your ancient pain system, built to drive repair behavior, fires into a void. So what do you do with all of this? The answer isn't to become numb to rejection. The pain response exists because belonging matters. Connection matters. Your brain is not broken for hurting when someone pulls away. It's doing exactly what it was built to do. But knowing the machinery behind it changes the relationship you have with the pain. The next time rejection hits and the hollow weight settles into your chest, you can recognize what's actually happening. Your brain just fired an alarm designed for a moment 50,000 years ago. The alarm is real. The threat it's responding to most of the time is not. You're sitting in a waiting room. A stranger walks in. You don't know them. You'll probably never see them again. And yet within seconds, something in your brain has already started calculating. That calculation, that ancient, automatic machinery, once kept your ancestors inside the safety of the group. It kept them fed, protected, and alive. The next time someone doesn't text back, remember, your brain isn't being dramatic. It's being exactly what it was designed to be. A system that learned over millions of years that being left behind was the most dangerous thing that could happen to a human being. The pain you feel is the oldest warning signal your species ever developed, and it still works exactly as intended.